Chapter 4 is our chapter on probability, and in section 1 we're going to talk about an overview of what a probability experiment is, probability as a whole looks like, how we compute it in certain situations, and kind of vocabulary, I guess, some things that we need to understand as we move through the chapter. Now, I do want to apologize that I am at home now and not at school where I can write on the smartboard, and so I have a tablet that is sitting beside my laptop, and I have to draw on that tablet, and then my mouse shows up on my computer screen. So I'm not terribly smooth with it. My handwriting will not be nice, but we're gonna make do with that because I can't go into town right now and work on campus. So when we talk about a probability experiment, I need you guys to read your books. I'm not going to write all the vocab up here on these slides because you can read the text boxes and see and understand what's going on. But probability is typically a chance process. If I flip a coin up into the air, whatever side it lands on happens by chance. If I draw a card randomly from a deck, pick a card, any card, and I pull it out, that choice is by chance. If I roll a die on the table or even a pair of dice, and then count the sum of the dots, okay, those outcomes all happen by chance. Those are probability experiments, you could say. When we talk about the sample space, get it oriented here. When we talk about the sample space, we're talking about a list of all the possible outcomes. It's very frustrating because I can write better than that. And again, when we're talking about these types of experiments, we're not necessarily talking about numerical outcomes. If we're talking about our experiment being flip a coin, our sample space is that we could get a head or we could get a tail. If I roll a single die on the table, then my outcomes are the numbers 1 through 6. I could roll a 1, a 2, a 3, a 4, a 5, or a 6. If I were to draw a card out of the deck, there would be 52 elements in that sample space. I'm not even going to start writing them down. I'd have the ace of spades, the 2 of spades, the 3 of spades, the 4 of spades, all the way through. And we'll talk about the setup of a deck of cards here later in case some of you aren't familiar with how a card deck works. Maybe I want to flip a coin twice and then write down what happens. I know that I could flip a head and then another head. Or I could flip a head first and then a tail. Or maybe tails first and then a head. Or maybe both of those guys were tails. There are 4 things in my sample space there. Think about flipping a coin 3 times. And make a list. Go ahead and pause the video in a second and make a list. Of course, one option is that I have 3 heads right in a row. You should have a total of 8 things in your sample space when you're done. Your possible outcomes, there's 8 possible combinations. Pause the video, write them down, and see if you can get them. When you unpause the video, they're magically going to already be there. So pause now. Here's our 8 outcomes. That last one says tail, 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 and the squiggly crazy thing is supposed to be my other bracket. Okay, so if I flip a coin 4 times, there would be 16 outcomes in my sample space. When we're talking about probability, there are really 3 different types of probability that are out there. One of them is called classical probability. One of them is empirical probability, and one of them is subjective probability. Classical probability is like what we listed on the last page. When we are looking at something like flipping a coin or drawing a card out of a deck or doing some sort of experiment like that, the way I always describe it is in a perfect world. Okay. So in a perfect world, if I'm going to flip a coin, we should get the same, get a head half the time, and we should get a tail half the time. Okay. A sixth of the time, we should get a 1 or a 2 or a 3 or a 4 or a 5 or a 6 when we roll a die. Okay. Classical probability is when our outcomes are equally likely. Let me say that for equally likely. So when I flip a coin, I have the same chance of getting a head as a tail. I have the same chance of drawing a 3 of clubs as I do the 4 of spades. Okay, but my outcomes are equally likely in classical probability. And again, when we're computing the probabilities here soon, we think about what would happen in a perfect world. Empirical probability is our experimental probability. Okay, that means I actually go do an experiment and talk to 5 dentists about what toothpaste they like best, and then I say 4 out of 5 dentists choose Crest, or whatever the commercial used to say. But from my experiment and what actually happened, that's how I compute those probabilities or describe the likelihood of something happening. Subjective probability is making an educated guess. Okay. So the best example that I have of that type of probability is the weather. Okay. When they say there's an 80% chance of rain tomorrow, that of course has a lot more computer assistance now than it did even 10 years ago, but when I was growing up it was a whole lot more guesswork, and now it's very computerized with lots of algorithms. But still, when they say it's probably going to rain tomorrow, that's not a guarantee. When they say, well, the high is going to be 60 and then it's 40, okay, that was just their best guess from what the weather patterns were, what their computer prediction software said, kind of point in the right direction, okay, to make that educated guess. So when you come back to the next video, I think that's a good summary for now. We're going to talk about actually computing some of these, and the computing that we're going to do some classical probabilities, and then also talk about how to deal with empirical probabilities. Subjective, not really up our alley for the scope of this class. So next video, we'll have some actual numerical computations and a little more explanation.